Good morning, Nana. So, already I told you that we are going to revise our IIT program, what we discussed so far in our 8th class. We'll revise it in summer. So, today onwards, I'll post a at least a 10 minutes class in the group. So, everyone, please follow the class and try to do the problems. And later, I'll give you problems. You have to solve it in a notes. So don't throw out your notes. 8th class IIT fact notes. Okay. So don't throw it out. Keep it with you up to 10th class. Because we are going to continue our program in 9th and 10th class. Okay. Wait. So in today's class, so we are going to discuss about mathematical physics vectors. In physics, you all know that we are measuring our physical quantities with the units. For example, to measure the mass, unit is kg. To measure the time, unit is seconds or minutes or hours. To measure distance, displacement or length, whichever it is, we are using millimeters, centimeters and meters. So here we know some physical quantities like mass, time, distance or displacement. All these things are measurable. So we are calling those as a physical quantities. So when you separate these two, few are vectors, few are scalars. Vectors, the physical quantities which has both magnitude and direction, are known as vectors. The physical quantities which has only magnitude but not direction is called a scalar. An example I will write. Force. You all know that force is a physical quantity with the unit as a Newton, with the unit as a Newton, and it is denoted with the letter capital F. Denoted with the letter capital F. Now I will say this is a vector physical quantity. This is a vector physical quantity. Force is a vector physical quantity. How? It has both direction and magnitude. Let me try to explain you what is magnitude. Suppose this is a block. This is a block of mass m, and you are pushing this block with this force. This force. And in second case, you are pushing the same block of mass m with this force. So you just observe which is a greater. It seems that this is a greater. Force is greater here in second case. Observe this, this is a smaller force and this is a larger force. In letters itself, you may identify this one. Suppose when you want to say how much it is, so we are giving this a strength as a magnitude, strength as a magnitude. Suppose this is a 4 newtons. 4 newtons force is applied on this mass, and here it is 8 newtons. Observe, according to this size, I have given a number as a magnitude. Magnitude, size, how large it is, how small it is. In these two cases, after experience 4 newtons force, This may move, may not move. And after experiencing this force, 8 newtons, it may or may not move. Still, we are giving the name it as a force, and the magnitude of force is a 4 newtons here, and here it is a 8 newtons. Now, I hope you understand what is magnitude. It's a size, how much we are applying on this. So, this is about magnitude when we are discussing about a force. Suppose I have a vehicle, I have a wheel here, and I am pushing it. It is moving towards right side with velocity u, and the same wheel, and I am pushing with a force. It is moving with the u. Observe this. So, which wheel is it? This one or this one? Which experience or which is moving with the more velocity? So you can say this one. This is moving with the larger velocity. So magnitude of this velocity is high. So from these two examples, you came to know what is magnitude. That is nothing but the size or the strength of that physical quantity. The size or strength of that physical quantity. In our daily life, we are observing so many things, not like this. Now, I will denote a vector with the r bar. I mean, this is a position vector. This is the 2 units along x-axis. So, how can I say this one? Students, this is not regular class. This is just revision class. Okay, I will give you the key statements only. Okay, look, r bar is a position vector is equals to 2 cap. Here 2 is magnitude along x-axis. Along x-axis I cap is a unit vector. We have 3 unit vectors, I cap, comma j cap and k cap are the unit vectors along x-axis, y-axis and z-axis. Suppose if I am writing like this, r bar is equals to 2 I cap. This 2 is a magnitude and this I will give you information that this is located on the x-axis, Suppose if I extend this one, 2I plus 3j, and now this is a position vector of a object in the plane x, y, because already I told that I cap is a unit vector along x-axis, j cap is a unit vector along y-axis. Let me denote this one on x-y plane. This is the y-axis, this is x-axis. Horizontal axis is always x-axis and the vertical axis is always y-axis. And we have third one, z-axis, which is the imaginary axis towards u. And suppose if I want to denote this one, how I am going to denote it? Observe. 2 units along x-axis, 1 unit and 2 unit. This is along x-axis. I mean, can I write like this? 2 I cap? Yes, I can. And 3 units. 3 is a magnitude and j is a direction. 1, 2 and 3. So after coming here, just to go through this straight line and you can reach this one. And finally, this is your given vector r bar and here it is 3 j cap. So this is how we are going to locate this r bar on the plane xy plane. Observe this one. So I'll give you few physical quantities which are both magnitude and direction. Velocity momentum, force, acceleration. So we have a lot. And some physical quantities which doesn't have direction. Mass, time, distance, density. So there are physical quantities which has both magnitude and direction. Magnitude, direction. Already I told you that magnitude is what? So size or strength. Now I will give you information about direction. So one example I will take to explain you about the direction. This is a mass. Do it has any direction here or irregular shape? It may have regular or irregular shape. Okay. So definite magnitude will be there, either maybe 2 kgs or 1 kg. That number will give the information regarding magnitude, and there is no direction for this. And now I am going to apply a force on this. Force on this. So we have lots of chances to apply a force on this in either in these three directions. We have a lot, but I'll choose these three. Observe this F1 and this F2 and F3. And here it is placed on a plane. On a plane. This is the plane. Or floor you can take. Now, F1 is applied along the direction of floor. This is the direction of floor. You floor along it. So this is these two are parallel to one another. And observe this one. This one. F3. F3 is applied on this block perpendicular to this one. Floor. Perpendicular to the floor. And F2 is the force which is not perpendicular and not parallel. It is applied. It is applied at an angle theta. So you are giving this one as angular displacement. Angular displacement. And F2 is directed not along the floor and not perpendicular to the floor. And it made an angle theta with the horizontal. So what happened? This F2 is split up into two directions. One is along F1, second one is along F3. Now I will write like this. Look, this force is resolved into components as Fx and Fy. Fx is a force which is resolved from F. Fy is a force which is resolved from F. And this information you can observe. Since force is a vector physical quantity, it is resolved into components. Okay, every vector will resolve into two components, Fx and Fy. And the vector is in the form of F is equals to Fx I cap and Fy j cap. And now, after observing these two, we just separate, you can write the similar physical quantities like this up to 10. So I have given 4 and you can write it as a 10. Continue it up to 10. And draw the same picture for velocity, momentum and acceleration. Okay, so this is a today's exercise for you. What is that? Draw the same picture for velocity, momentum and acceleration and write at least 10 vector physical quantities on left side and 10 scalar physical quantities on right side. In tomorrow's class, I will explain the Sunday work. So in our school, at the beginning in June or July, we have, I think we started Sunday worksheet for you all. 5 problems in each Sunday. So from today's class, I have started my revision class, and in tomorrow's class, I will discuss the problems which is given to you on Sunday. Okay, please open that book, keep that book with you. Already I told you to keep a book for that and worksheets with you. And I will post that worksheet and I will explain each and every problem how to proceed. But calculation you have to do. Okay, I will explain the concept behind that problem and you have to calculate that. Okay, so note this diagram in a different book. So tomorrow we will meet with the problems and another concept.